Okay. So now we're going to talk about cost determination in this Mismach Yizum. Sorry that this is in Hebrew, but I'll explain it all, and I hope you won't mind. So it's called COCOMO, which stands for the first letters of constructive cost model. So because it means what we do is we construct a cost model. Or wait a second. Okay. So first of all, we have to distinguish between three kinds of systems. There's organic, semi-detached, and embedded. Embedded is like a small system on like an actual, thing, like a washing machine or a jet plane. Organic is usually like a large software project. And semi-detached is something in the middle. So this could be like a real-time thing embedded often. So organic. So actually a little bit different from what I said. Sorry. Organic, it says here, is a small group of programmers and a complex system, but it is on a jet plane, you see. But it's a complex system, but in-house. And you want to, and usually have, in other words, what we're distinguishing here is between different kinds of projects. There's basically these three different kinds of projects: organic, and embedded, and semi-detached. I wish I had, wait, let me, here's a nice table. So look, organic is small. So if I said it a little bit wrong before, typically 2 to 50. Anyone can guess what KLOC stands for?
I actually heard it used the other day. Thousands lines of code.
Very good. 1,000. K is kilo. Kilo lines of code. So it's usually 2 to 50,000 lines of code. I mean, I don't know who came up with these definitions. This is Methoda came up with these. I do know who came up with this, but this company that made this, this Israeli company. So a project size is usually 2 to 50,000 lines of code. If semi-detached is usually 50 to 300,000 lines of code, and embedded is usually over 300,000. So organic is a small project, small team. Development team is familiar with the application, language, and tools. Usually, because you take a small group to do a good job. But it's organic. I don't know why organic is the word they use exactly. Innovation is a little innovation. It's something it goes together. They're familiar with the application because they've done similar things before. It's not so different. Deadline and constraints are not tight. In other words, it's not as important if I finish exactly on time. Development environment is stable. We know the environment, and maybe it's even in-house. We have our own IDE. An embedded system is very large group of people, more innovation. Usually there'll be more innovation. You're doing something, you have a large group, you're doing something interesting, new. I mean, I a little bit don't understand this definition, these differences, because couldn't you have a small group doing a tremendous innovation? People who, I don't know, I'm not sure, like, maybe not. Here, when you think of embedded, think of like designing the computer on board the spaceship that lands on Mars. It's embedded in the spaceship. It's for that purpose. It's got a lot of innovation. It's a brand new thing. Nobody ever did this before. You have a huge team working on it. You have severe constraints. It's got to fit on that machine. It can't be it has to work at a certain speed. It has to have certain energy usage because you don't want to drain the batteries of the spaceship. Development environment, it could be very complex development environment. Hardware, complex hardware, customer interfaces. You have to be able to, access it directly from Mars, to here, and it has to have all kinds of interfaces and complicated hardware. So think of that. Organic, you might think of like a video game. Atari's or whatever, some company's next video game, usually a small group will work on it. It's not really innovative because, maybe nobody ever did a video game called this with these kind of things, but it's basically using technology that's already been used. We've already made video games. We know how to draw pictures on computers. So it's little innovation. And semi-detached is the medium of all of those things. So that's kind of a summary of what it says in all of this Hebrew here. Here it gives examples of here. It says organic could be modelim shel minhal asakim, some kind of model that a business manager wants to create for like managing his company, or keeping track of inventory, or even like a scientific model of how virus behaves. You can make a model of it. Those kind of things would be small, in-house, small team. That's organic. Semi-detached would be some kind of transaction system, a system that deals with transactions like in a bank or something, or something that monitors a factory. It has computers, has robots, a robot factory, a factory that creates things by robots. Or even a new operating system. See, that's bigger than a video game, but it's smaller than the controls for a spaceship, an operating system. So command and control is like missile guidance systems and things like that. That's a bigger thing. And that's why it's embedded. It's like part of the hardware. It's built for a specific device or specific device. It's not generally sold to the public. It's for a particular missile system. Here it says also image processing, advanced image processing. Okay. Now we're going to get into some math here, very simple math though. What happens is like this. This company, they did a survey of all these projects, because remember, we're trying to figure out how much our project is going to cost. So we have to figure out what kind of project is it. Is this embedded? Is it organic? Is it semi-detached? Is it how big of a project? What type of project is it? How many lines of code do we think it's going to be? So the first thing they did was they did a survey. How long do projects take on average when they're organic, when they're semi-detached, when they're embedded? And they came up with the following information, that it depends on some various factors. So, for example, like this, let's first start like this. They came up with effort, which is Chodshei Adam. Remember that book I mentioned before, the mythical man month? This is Chodshei Adam, is man months. So if you want to know how many man months it will take, which we're going to call effort. In other words, effort is measured in man months. Now, what is a man month? It means if it's 1 man month, it'll take 1 man a month to do it. If it's 1 man month, it could also take 2 men a half a month to do it. That's still 1 man month. Or 4 men a week to do it. That's a man month. So if it could be 20 man months. I might hire 20 people and I can do it in a month. Or I'll hire 10 people and do it in 2 months. So that's man months. So if we want to know how many man months, what we do is we take our estimate of the how many thousands of lines of code, and we multiply it by A, and we also raise it to the power of B. I guess first we raise it to the power of B, and then we multiply it by A. So what are A and B? So A and B are just these numbers that they figured out what they must be based on running analysis of previous projects that were also, that, and they found that A is not constant. It depends on what kind of project it is. If it's an organic small project, then A is 2 times 0.4, because a small group of trained people is going to work a little bit faster than a large group. So that's why this is 3.6.
What does it mean to quantify effort?
That's what we're doing here, quantifying effort. What does it
Yeah,
mean?
but like, I don't know what that means. To like assign a number to the effort.
It means if we come up with the effort being 12, it's not just 12, it's 12 man months. It means it'll take 1 man a year to redo this project.
Ah, fine. That number. Okay, fine. I didn't realize that. That
That's what
number.
it is. That number
how many
is man months.
Okay, fine. Yeah, I didn't get that.
We call it effort, and it's measured in man months. Man months is a unit. A unit called, there's a month unit, there's a man unit, and then there's a man month unit.
What's the clock?
1,000, we talked about that. Thousands lines of code. Kilo lines of code. Got it?
Yeah.
Okay, so then we just multiply these numbers. 2.4 times how many lines of code raised to the power of B. Well, you notice that B doesn't do much, because if it's raised to the power of 1, it does nothing. So raise the power of B 1.05. If it's a small group, it will make it a little bit longer. If it's a big group, it'll make it, that B will make it a lot longer, raising it to 1.2. So again, you see that the numbers go up. That kind of makes sense that the numbers go up when the group gets larger, because of that rule that we told you, that I read to you before, that it says that if you add more people to a project, it gets slower, not faster. So when you have sometimes you need a big group. You can't say, I'm going to hire, 3 guys to do something. It'll take them 30 years, and then I'll have this thing. You can't wait 30 years. Sometimes you need to finish it. So you need to hire 300 people and get it finished in a short time. So you have no choice. But then he's just going to calculate, okay, I'm going to hire 300 people. How many man months is it going to take me? So if it's a big project, you'll raise it to the power of 1.2, and your coefficient will be 3.6, not 2.4. So that will tell you how many months. Now, once you've got how many man months you got, you then want to compute, well, how many people should I really have? How much time should it really take? In other words, it's kind of absurd. Sometimes if you have a big project, you can't say, well, I'll hire one guy and it'll take him 100 years. It might be that one guy will not be able to do it in 100 years. In other words, well, he'll die, but maybe I'll hire 2 guys and it'll take me 10 years. But it may be that it's just totally inefficient to do that. I want to know what's the ideal number of people to hire and what time should logically take me. So the first thing I'm going to figure out is how long this project should take me. So if the effort, so we've now figured out that it's 100 man months, or whatever number we got here. If we then take that and multiply it by 2.5, but first raise it to the power of D, which if you raise it to a small power like this, it actually makes it smaller. So, which makes sense. We want the number to be smaller. So if the effort is 100 and we raise it to, let's say, 3.5, if it's a big project, we'll raise it to 3.2. So that'll make it become like, I don't know, square root of that number, or even less.
Around 4.36516.
What?
Approximately 4.36516.
If what? If you raise 100 to that power?
Uh-huh.
So it becomes from 100, it's the double square root, kind of, right? The square root of, because this is like almost a quarter. So if it would be a quarter, it would be the double. So the square root of 100 is 10, and the square root of 10 is about 3, something like that. So it's less than, so it's 4. It's not quite the double square root. But anyway, we get it. We're gonna get like 4 something months. Then we multiply it by 2.5, and we're gonna get like 4 times 2.5 is about 10, let's say. So we're gonna say this project is gonna take this 100,000 lines of code is gonna take us 10 months. Now we already figured out how many man months it is. If it's 10 months, we can figure out how many people we need. We take man months divided by months, and we're left with man, right? You have man month divided by month, you're left with man. That's the staff. So once we figured out how many months it's going to take us, we can figure out the logical number of staff we should have. So I don't know what it is, but it's some number. And that tells us already, that helps us answer this question. Remember we said we want to make software engineering like building bridges, so that I can actually quantify and actually know how, what to write on my document, that how long it's going to take me, et cetera, et cetera. So this is the first stage. We'll stop here, but it goes on. It's not the end of the story, but that gives us some parameters for measuring, time for a project and staff for a project.
Is this
Alright.
the same link as Unix, or we have to go out and come back in?
You have to go out.
It's like a completely separate link.
I put a link in for Linux, so let's use that.
But I'm saying, is it the same link, just put in both?
No, it's
We-
different.
We have some professors who use the same link for all their classes.
No, I do not do that. Although
Okay,